My name's Ari. This is
I'm Gio.
We're doing a Calculus 150A group project, and we're going to be demonstrating how to solve the problem.
This is going to be part A.
I would like to read the problem and highlight a few areas of it. The Postal Service will accept a box for domestic shipment only if the sum of its length and girth, distance around cannot exceed 108 inches. What dimensions will give a box with a square in the largest possible volume? So, from this problem, we know that the sum of its length and girth, we're going to need to find that. And we know that it cannot exceed 108 inches. And we would also have to find the dimensions. We know that there's a square end. And we need to find volume, the largest possible volume. So we know that we're going to have to maximize this problem. So with the equation, we know that volume is length times width times height. As there. And so we would look at our box. So this is our rectangle. And we can label it. He's labeling y for the length and x for the side. And we know that it's a square end. So it's going to have 4 x's. So we can simplify this equation as being volume equals x squared times y. And we are going to be solving for our length and girth. So we would say, with this equation, we would say y plus 4x, because there's 4 x's, equals to 108 inches.
Okay, so now we're pretty much just simplifying it, just solve for y. So I'll just do some algebra real quick.
So our y is equal to 108 minus 4x.
So now pretty much we're plugging this y to here. So okay, so just to do some algebra real quick. Okay.
So now that we have this equation, and it's simplified as far as it can go, we are going to be taking a derivative. And our derivative will look like this. And we're going to set it equal to 0 to find our critical points. So we're going to pull out a 12. So we know by this that our 2 critical points would be 0 and VT. And this is our x equals 0 and VT. Now that we have this, we are going to put this, back into our
So pretty much we're just trying to find the max and min by plugging these numbers into the original equation.
So we'll put our equation here. So if we have V as 0, we know that that is going just to be equal to 0. If we have a v of 18, it's going to be equal to 1. And that is equal to 11,660. So we know that this is our max.
Okay, so now that we know this number and we have 18, we're plugging in to this equation. So to solve for y. See, we're just trying to solve for y now. So this will be this will be 324. So now we know that y equals to 36. So yeah, we have our x value and we have our y value and our volume. So our x is 15, y equals to 36, and our volume equals to 11,664. And that's it. That's it.
Hi, I'm Sarah, and we are going to do part B. So we are given a box with square ends, so the dimensions are height by width, and we want the largest volume, and we have a restriction of 108 inches. And knowing this and given this information, we know two equations, which are volume equals h squared w, and a girth equation, which is g, which is our girth, equals 3h plus 2w. And knowing these two, we are going to solve for our width.
Remember how I said, like, Dave's not really scared of my excuses, but I felt like I was like, alright, I gotta go, I gotta get my friend. My book had my car, I'll be right back.
Okay, so now we have an equation in terms of w, and we have our volume equation. So now, since we know w, we're going to plug it into our volume equation, which is okay. So now we have an equation in terms of volume, and on that note, we derive and simplify this equation and set it equal to 0 to find our critical points, which T will demonstrate for us.
So our equation is 54h squared minus 3 half h third. Now we will derive it and get 108h minus 9 half h squared. And then we set it equals to 0 to find critical points, which are 0 and 24. Okay, so now we plug 24 back into our original equation.
30 minutes?
And get 1,360. So that's our volume, and 24 is our height. So now we plug it back into the original equation, which is V equals h squared W. And we know our height is 24 squared times W. And W equals 18. So we know that our height is 24, W is 18, and our maximized volume is 1,368.
Change only, 10,000.
That's it!
I'm losing my hair and my vision is shady. Last night I dreamed of an overweight lady, but I need a young thing to keep up with my pace, to hold me in her arms and take me straight to second base. I know my calculus, it says you plus me equals us, yeah. Oh, singing chair on the phone, man. I know my calculus, it says you plus me equals us. Oh yeah, calculus. Yeah. We together. Girl, algebra or trigonometry can never equal up to what you do to me. So let's integrate, don't differentiate. If you were in my class, there ain't no way I can pass. I hate English, gym, and not to mention I can't even afford to pay my attention. No philosophy could ever come between us, but we'll always have our calculus. I know my calculus, it says you plus me equals us. Yeah, I know my calculus, it says you plus me equals us. Come on. Ooh, baby. Oh, Lord. Yeah. You plus me equals us all. Come on. Well, I've never been good at history, and I don't give a crap about Robert E. Lee. When it comes to cosines, I know a thing or two, and I think that's on the test about me and you. I know my calculus, it says you plus me equals us. Said I know my calculus, it says you plus me equals us. You plus sign me equals sign us. You plus sign me equals sign us. Girl, no subject comes close to you.